So the second question of LeetCode Weekly 382 contest is find the maximum number of elements in subset. Okay. Now in this question, you're basically given a zero index array nums, and what we need to do is we basically need to remove a subset of integers such that these subset of integers can be placed in a different array in such a way that that array is in such a following format, right? So there is x square, x power 4, dot 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 till x power k by 2, x power k, and then it goes back down to x power k by 2, and then x power 4, x power 2, and x, right? So it's basically increasing and then decreasing at some peak, right? So for example, here, this is basically 2 power 1, this is 2 power 2, and this 2 power 4, and then it's going back down to 2 power 2 and then 2 power 1, right? And here there is 3 power 1, 3 power 2, and 3 power 1 again, right? So these both patterns are in the format that is required. Also, we need to note that the highest number, which is like the peak in every array, will be a non-negative, will have a power that is a non-negative power of 2, right? So here it's mentioned that note that k can be any non-negative power of 2. Okay. Now it has to be a non-negative power of 2 because the powers are increasing like the powers of 2, right? So it's 1 year, 2 year, 4 years, then there'll be basically 8, 16, and so on. So this k value will also have to be a power of 2, right? And what we need to find is we need to return the maximum number of elements that we can put in the subset such that it satisfies these conditions. Okay. So if we look at the sample cases, we have the array 5, 4, 1, 2, 2. Okay. Now, if we pick up the subset 4, 2, 2, we can basically rearrange them in such a way and make it as 2, 4, 2, where 2 is basically 2 power 1, this is 2 power 2, and this is 2 power 1 again, right? Now, here x can also be any number, right? So, yeah. And here, the only thing you can pick up is a subset of size 1. So, here we picked up one number, and yeah, that's the only number in the array, right? And the constraints in this question are the length of the array is minimum 2, and maximum it can go up till 10 power 5 as well. And every value in the array can be from 1 to 10 power 9, right? So yeah, let's see how we can solve this question. Yeah, let's see what is the required format here. Now here the required format is this one, right? X power 2, x power 4, x power dot 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 till x power k by 2, x power k by 2, and then so on back till x power 1, right? So what we can do to solve this question is we can iterate over every possible x power k values, right? Okay. Yeah, we can iterate over every possible x power k values, right? Now, what does that mean, right? So basically, we consider every number as a possible x power k, because for every any format, I mean, after taking a subset of elements, there'll always be some x power k value in that, right? Even if it's a single element, so even if it's like a single element like 2 power 1 will be the only value present in this, and this value will be x power k value where k equals to 2, right? Right. So basically, x power k element will always exist, right? Now, what we do is we go through the array and we fix every number as x power k, and we find the maximum subset that is possible by fixing that specific number as x power k, right? Now, it'll all be clear when I dry run the approach through this test case. Okay, just a second. Yeah. Now, first thing we do is we also store this array into a hash map. So we basically store the array and array values and its frequency into a hash map. And why we are doing that, that will also be clear in a moment. So for this array, how would the hash map look like? Hash map, okay. You can use a hash map or any regular map as well, as long as you have the frequency values, right? So here, 2 has a frequency of 2, 1 has a frequency of 1, 4 has a frequency of 2, 16 has a frequency of 1, 7 has a frequency of 1, and 3 has a frequency of 1, right? So basically, this is the entire hash map, right? Okay. Now what we do is we iterate over this array. Okay. So I'll just write this array down again. It's 2, 1, 4, 7, 2, 16, 3, 4, right? So 2, 1, 4, 7, 2, 16, 3, 4, right? Now, when we iterate through this array, we consider every number as a possible x power k, right? So let's come at 2, right? Now, if 2 is a possible x power k value, then what is the maximum length of the subset that we can achieve, right? Now, if this is x power k, then what will be the values that are beside it? Basically, if you look at the format here, the values beside x power k are basically x power k by 2, right? So if 2 has to be x power k, the values that need to be uh, beside x power k would be x power k by 2 and x power k by 2, right? Just a second. So yeah. So for 2, the only possible k value would be 1, right? So 2 can be written as basically 2 power 1, right? And we cannot have any values adjacent to it. So with 2, the only possible array subset will be of size 1. Okay. Now for size 2, let's see. I mean for the second element here. Okay. For second element, if we have 1, again that's the only possible array that is possible. Okay. Now let's see for 4. Okay. So for 4, now if 4 is the x power kth value, what can be the possible k values here? K value can be basically 2, right? Because 2 power 2 will give us 4, right? Now, since the powers are always, you know, powers of 2, because of that reason, we can always try to choose the highest one, right? So let's say if we have a number like 16, right? Let's say if we have a number like 16, then we can definitely write it as 4 square, right? But it will be beneficial for us to write it as 2 power 4 instead, right? Because 2 power 4 will give us more ways of expanding, exactly, right? And whatever this power is, that's basically just the root of 16, right? Because only those two numbers, when multiplied with each other, will give 16, right? So what we do is, in every single iteration, we basically say 4. Okay, we have 4. And what are the possible two numbers that when multiplied will give us 4? Basically square root of 4, right? So 2 and 2 when multiplied will give us 4, right? So from 4 we came to 2 and 2, and we check whether 2 exists in the hash map. And yes, it does exist in the hash map. And 2 has 2 occurrences of 2, right? So since 2 has 2 occurrences of 2, this will basically be the x power k element, and this will be the x power basically k by 2th element, right? Now we know from this case that we cannot expand 2 further from here, right? So in this case, the maximum possible subset size will basically just be 3, right? So it's 3 because we have 4, 2, and 2, right? Now let's go to the next number. Okay, so I'll erase this part. Now, if we consider 7 as the x power kth element, so 7 is the x power kth element. Now here k value can be only 1, right? Now we try to expand it, right? Now we observe here there is no possible way of expanding it further because two integers multiplied can never lead to a value of 7, right? So we stop right here. Okay. So with 7, the maximum possible length will only be 1. Now with 2, again, it's the same thing. It will only be 1, right? Now with 16, what will be the length, right? Let's see. So if we have 16, we can split 16 into 2 ways. We can say we have, not 8, sorry. We have a 4 and a 4, right? Because 4 and 4 multiplied will give us 16, right? And that's why if 16 is x power k value, I'm sorry. If 16 is x power k value, 4 will basically be x power k by 2th value, right? Only then, when we do x power k by 2 into x power k by 2, it will give us x power k, right? So that's why we do a square root, okay? So at every single step, we do a square root, okay? Now, 16 is basically x power k value, right? So from 16, we derive 4 and 4. So we have x power k value and we have 2 x power k by 2 values, right? And we check the frequency of 4 in the hash map. So 4 occurs 2 times here, right? So it's possible for us to place 2 4s, right? Now from 4, we also expand again, right? Basically, this should be x power k by 4th value, right? Which is basically square root of 4, okay? And now we check the frequency of 2. Even 2 occurs 2 times, right? So even this is possible. Now we know that we cannot move further down from this. So here our maximum possible length will basically be 5, right? 1, 2, 3, 4, and 5 elements, right? So in case if we had only 1, 2, let's say, in case we had only 1, 2, sorry, yeah, in case if we had only 1, 2, then in that case, our answer would not be 4, it would be 3, because this 2 will never be included, right? See, in our format, when we have x in the beginning, we have x in the end, right? So every number is being repeated twice, right? Except the middle number, except the x power k number, every number is being repeated, right? So except 16, every other number has to have at least 2 occurrences, right? So the frequency of the element should be at least 2, okay? That's why if there is only 1, 2, our subset will include only these 3 elements, and in that case, the answer will be 3, okay? So that's what we basically do. At every step, we basically fix this number as x power k, and we find the square root of that number, check if that square root of the number has at least 2 occurrences. If it has 2 occurrences, then we add those 2 into our count, and we keep going down from that, right? So initially, the count will be 1. If the square root exists and it has 2 occurrences, then the count will be incremented with 2. And if the square root of that also exists, then and it has 2 occurrences, then it will be incremented by 2 again, and it keeps going down, right? And basically, sum of all these counts will give us the answer. And if you notice, the sum of all these counts will always be an odd number, okay? Because 1 in the beginning, and then this sets of 2's will be added, okay? So yeah, this is how we solve the question. And the time complexity of this question is time complexity O is O of n log n, okay? Not log n, basically, because we are considering numbers instead of the array length, right? So it will be log of a of I, okay? Why log of a of I? Because at every point we are doing a square root function, and we are going down, right? So it's decreasing in a logarithmic way, right? So 16 will become 1 in log 16 time, log 16 base 2 time, right? So the time complexity of this approach will be n log a of I, okay? And yeah, that's how we solve the question. And the complexity of storing in the hash map will just be O of 1, right?